Hi there, welcome back to the channel and to the third video in the restoration of this Philips 148. And let me show you something. We have progress. We have progress. And it took quite a while to get here. It took almost as long as it took for the tubes to arrive here. The tubes arrived. I was told they were at the post office, that they were going out for delivery. And the next thing I saw on the tracking was we could not go to that address. What that means, I don't know. I mean, they've delivered hundreds of packages to that address. I think probably because of the fact that it's August, a lot of people on holiday, and they're short of staff or whatever. So I ended up having to pick them up at the actual post office depot, and they were kind enough to give it to me. But anyway, the point is, tubes arrived. I did quite a lot on this to get it to work. It wasn't just the tubes, but for that, you'll have to stick around and watch the video. I hope you enjoy it. The replacement tubes have finally arrived. The post office finally thought I was worthy of receiving them. They sat there for about 2 weeks. Don't ask me why. But anyway, I've got the tubes. They are, of course, the European equivalents. These are the originals. These are the European equivalents. I got 2 of each. In the case of the DF91, which is the 1T4, it uses 2. So the 2 new ones are basically here without spares. But I'm hoping I won't be needing all of them because I don't really know which ones are dead. Now, I've been told that this little bugger here, 1S5, is notoriously bad, has a habit of going off first. But what I'm going to do is I'm actually going to replace them all first. I'm going to replace all the tubes, see if I can get this thing to work. If it's working, then I'll start removing them and replacing with the original ones one by one and see exactly which ones are bad. That's my best tube method, tube tester method. So let's get cracking. I've still got the heater supply being supplied by my current limited power supply. Here it is. I've set that to 8 volts with a 50 milliamp current limit. That's the current that this series of tubes, this series string of heaters requires. 8 volts might actually be a little bit more than it needs, but because it's current limited, it'll settle itself down to the current that it requires, and it'll tell me exactly what voltage I have across there. I've got my power connected over here. I have a speaker connected. So here's the antenna. I'll just touch it when I get some noise and see what happens. Now, this is it. Moment of truth. I'm going to switch on the heater and the supply at the same time. Actually, heater slightly first. This should take a little while because that tube, the voltage regulator tube, takes a while to heat up and it's got a different supply. So I want to hear this. Well, that's good news. I've got some noise. It's on full volume. Let me bring the speaker forward. I can hear something, and my supply is at 8 volts, 50 milliamps. Now, why don't I let me try and tune this. Damn, still not getting much. What I'm going to do is, again, I'm using the internal antenna on this thing, and I'm going to connect that because this thing has got a big inductor effectively at the front end, and the radio might need that. This is on. Well, at least I know the audio is working if I touch this. Yep, so that guy's working. That one was sort of working, but now I do get audio. That's negative. That's the maximum volume down there. Okay. Now, do I get anything? Let's go from one end to the other. something happening right at the end there when the tuning capacitor is on fully meshed. That sounds like radio static. There's something there again, the other end. What the hell could be going on here? It seems like it's almost like the oscillator is not working. Let me connect the mini whip to this thing. You know, this coil could be doing very little. I'm connecting the mini whip in parallel to the oh, it's actually gone more silent. It's not what I expected. That doesn't sound too promising. Not promising at all. Damn. Let me do some thinking. Okay, I've decided to do the usual thing when you don't have an oscillator working, or you seem to not have an oscillator working, which is what I think might be happening, and that is to check the capacitor for shorts. Now, the capacitor looks very good. It's actually pretty well contained in the back there, so the usual reason for the capacitor being shorted is probably not likely. Usually when they're in the open, somebody touched it or whatever. But I'm going to check it for shorts, and it's got 3 sections. So, and I can see what's coming out. That's the ground. Let me give this a beep. That's the ground. And then it's got a common ground all the 3 sections. And then here's one. The first section goes straight to the antenna. No shorts there. You can tell from my tone that I've done this already. But the other one, where's the other one? The other one comes out here. No shorts there. And the other one comes out here. And look at that. I've got a short on the 3rd section of that capacitor. Now that would really kill it. So I'm actually feeling quite enthused. I'm feeling very enthused. And I'm going to try and look at the back there. I've actually had a look. I can't see anything wrong with it. I can't see the ends being bent in or something like that, but it's pretty far behind this, so I may be missing something. But I'm going to have another look at that and see if I can't unshort that. All right, just while I'm here, I want to show you something. I also did something else while I was waiting for these parts, and that is these capacitors. These 3 capacitors. A lot of you rightly mentioned that the grounds which I'd left, I disconnected from the ground, but the metal case is actually the ground of these caps. So when I used the positive tag as a convenient solder joint, I was actually putting the 2 capacitors in parallel, which was not a good idea. So I decided to do what I should have done initially, which is to restuff them. I took these out, I bored out the internals, I put in the new cap inside, I filled it with hot glue, with the proper insulation, of course, and now I'm using the can again because the negative comes out at that end. They're all connected to ground. So these capacitors are now new, but they've been restuffed, and I like the look of this. I didn't want this thing to have these massive holes on here. It just looked terrible. So let me sort out that shorted capacitor section. Okay, I've had a look at the capacitor. I can't see any shorts on there. It's still giving me a short, so I decided to desolder this, remove the connection to that section and test it out of circuit. Now, I'd be surprised if it's anything else because there is no pathway to ground from that position where it's at. So let's see. Oh, okay. No short. However, yeah, there we go. It's not the capacitor. It's something else. There's the main point that the capacitor connects to, and it's still showing a short, or you can hear it. Okay, so it's not the capacitor. Good. Let me start removing things from there. What do we have on there? Well, I see a small capacitor here. I see this thing goes to the tube. It can't be the tube. Well, let's find out. If I connect this to there and remove the tube, no, it's still shorted. So it's not the tube. Okay, what else do we have? Let's have a look at the schematic. We are testing, you see this is the 3-section tuning capacitor, there, and there. There's no short on there, you see that goes to ground, but I've tested from there down to ground, there's no short. Actually, I'm glad I had the antenna coil out, because that would have given me a very low resistance path to ground as well, but no short there, no short there. What about that one? That's the one that gives us the short at this point over here. Now I've removed the tube, so it's not the grid of that tube. That's one thing out of the way. What else do we have? We've got the capacitor itself. It's not the capacitor. There are actually two other capacitors. The small cap that I've shown you there is this one. And then there is a trimmer cap. That there, that middle one is a trimmer cap. Where else could it find its path to ground? Could it go through that coil? Through there? No, there's a resistor there. That capacitor could be shorted there. So what I'm going to do is I'm going to test these individually. I'm going to test that, and I know it's not that, so I'm going to test the things connected to that point over there. All right, see where we get. Okay, I'm going to remove, I think the easiest one to remove will actually be that wire going to the top there, because that'll isolate that capacitor. Okay, now we'll test it again, give it some sound, give the beeper. So that is not the capacitor, it's this, it's not the small cap, okay, it's this guy over here. Okay, wait a minute, that's the trimmer capacitor. That's really all that goes through there is the trimmer capacitor. Now, if it was that other capacitor, it would be from here to ground, and there I'm getting 3.4 ohms, whereas on here I'm getting 0.2 ohms. So it's not that path through the it's not the path through that coil. So it must be the trimmer cap. What happens if I do this? How the hell am I going to play with this trimmer cap? It's that trimmer at the top there. Oh. 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 Watch this. The trimmer cap is over here, and I'm just putting pressure on it, and it suddenly stops. That trimmer cap is shorted to ground. And if I put pressure, for some reason, I'm removing the short. Oh, that's brilliant. Let me try this all again. Cut the noise. Put this all together. Try and remove that while the radio's on. See if this thing works. Ha! I'm getting happier. All right. Everything is back in place. I've got the external antenna connected over here. And make sure everything's okay. I'm going to hit it. So heater and supply. Now, I should still get nothing for a start. Let's just see when we start getting some noise from the... Okay, now, I don't want to touch that. There's no high voltage there, but... Yes! Brilliant! Put the volume down. Can you see that? I'm just levering this forward. Okay, let me try put the mini whip on here now, because with that antenna I don't expect to get anything anyway. With the mini whip I might. This time of the afternoon I won't get much, but I should get something. Of course, I've got to lever this again. I love it. I love it. Canary Islands. Canary Islands again. FADO, local station, the only local station we've got. I love it. I love it. Let me put this off. Let me put this off. This deserves a coffee, a celebration before I go any further. I have found the problem. That little bugger there is shorting somewhere. Now where? Whether it's, I'm going to look around, I think it's probably internally shorting. This thing is actually, let me show you. Let me see if this is broken. It sort of screws on. And somewhere it is shorting. But at least now I know what to look for, and I know this thing's working, which is great news. I was beginning to think this is going to pull a Phillips on me, because they usually do. The Phillips do have these quirks. So I'm really pleased, and I'm glad it's not the tuning capacitor section, because that is way at the back there. You see, I'd have to remove this to try and get to the screws to remove the capacitor. I'm so glad it's something like that. And also, I've got a donor chassis with one of these. These things are normally about 30 picofarads, if I'm not mistaken. I'm not sure what this one is, but they're normally fairly low value. I could replace this with all sorts of things, even with an original Phillips one. So yeah, okay, good, good. Let me go have a coffee, celebrate, and then carry on. I want to show you something that sort of surprised me, baffled me. Now, what I've got is I've got this thing working, as you can hear. I'm putting the volume down. I've got 90 volts B+. I've got the heaters being supplied by the current limited power supply, 50 milliamps, not a problem there. And I've got 90 volts, 91 volts B+. The problem is that my variac is not at 230 where it should be, which is my normal supply. It's actually at 173 volts. So what is the problem here? What I did was, because I was using the power supply to supply the heaters, I wanted to make sure this thing was all controlled. So I gave it the 8 volts and made sure that it was happy with the 50 milliamps, not a problem. And then I slowly brought up the variac to make sure I got 90 volts. And I found that I was getting my 91 volts at 173 volts main supply. And it's still going through the dim bulb limiter. So it's drawing very little current. In fact, the schematic says it draws, I believe, 14 milliamps when on 90 volt supply. And I couldn't figure out, when I took that variac up a bit more, this thing went to 110 volts. Now, these tubes apparently can take it. I believe the output tube limit is about 150 volts. I haven't even checked what the others are, but they can take it. But this was not what this was designed for. And I couldn't really figure out what was wrong, because I do remember, I think on the first video, when the tubes weren't working but the heaters were, I think I was getting 90 volts at normal mains voltage. So I did some thinking again, and then it sort of made sense. Let me show you what happens when I run the heaters from the actual B+ supply. I've switched it on. I've soldered the heater wire, the actual heater supply, back onto the switch. So now my heaters are being fed by the actual B+. And look what we have here. We've got it working. But if I bypass the, sorry, just switched it off. If I bypass the dim bulb limiter, there's my 90 volts. And I thought, you know, how the hell does, 8 volts or whatever actually affect the B+? And then I realized I was being really, really stupid. This B+ supply is supplying the B+ to the tubes, which is a very small current of 15 milliamps apparently. But it's also supplying B+ to the heaters, and that is the full B+, 90 volts, at 50 milliamps, because regardless of whether the heaters are using 8 volts or 90 volts, the actual heater supply line is taking the full 90 volts. And that's quite easy to understand if we look at the schematic. You see, if we look at this heater supply down here, we've got our AC mains coming in. The secondary comes out here. Now it's set to the 240, 230, 240 volts. In fact, I think it's set to 250 volts over there. Yes, I believe it is. It's set to 250 volts. And it is providing supply to this, the secondary to this. This creates a B+ over here. And now what we've got is, we've got B plus 91 volts over here, okay? And then that takes the supply to the B plus, which is over there. And then this takes the supply to the heaters through these two resistors. So the supply to the heaters is 90 volts through two resistors into the heater line. And it doesn't matter that there's only about 7 volts over here, or 8 volts, whatever it's supposed to be. The fact is that the full 90 volts, the full B plus, is supplying the heater line with 50 milliamps. So in fact, you've got 14 milliamps going through that resistor, and you've got 50 milliamps going through there, which means that you've got 64 milliamps coming out of the tube. And that's why when I remove this section of it by supplying the heaters with the DC supply, I am taking away, what is it, 60% or whatever of the B plus current, and that's why this voltage was shooting up. And now when I connect this on there, what we get is the supply gets pulled down for various reasons. One is the voltage drop across the actual tube increases because more current is flowing. I think that's how they work. But more importantly, because there's more current flowing, the drop across the secondary increases as well. So this comes down to that nice and healthy 90 volts. I think I may have to increase this. I may have to actually change this from 250 down to 240, because let me show you. If I check the heater voltage, 7.01, it's actually a bit low. The full voltage that this thing requires is, what is it, 1, 2, 3, 4, 5, 6 times 1.4, 8 point something volts, 8 volts, which is what my main supply is doing. So that's a little bit low. I might experiment by changing this point here. This is where the wire is going to the 250 volts. I might change it to that one, which is 230, 240. In fact, I think it was there before. Somebody may have dropped that. I might change that to there and see what B plus I get and also what heater voltage I get. But for now, I'm happy with this. This thing's working beautifully. All right. What I'm going to do next is I'm going to start swapping tubes, see which ones were actually faulty, and see if any of these are weak. And I'm going to do that in a very, very simple way. By the way, I nearly forgot to mention this. That little bugger is now working. What I did is I wiggled it around, I pulled it out. I think the way that it was bent in was forcing this top cap to touch the bottom. You see this here is the top cap, which is normally the one connection. It's the ground connection. And this here, it sort of slides over cylindrically. That's the other connection. That's that point over there. And those two can't be shorted, and they were. So whatever I've done to this, I've fiddled around and the short is gone. And I've tried to get the short back, can't get it back. So hopefully it'll stay that way. When I actually do an alignment on this, I might recreate the short. So I have to be aware that this is possibly not the end of the story for that little guy. But for now, it's working perfectly well. So let me start changing these tubes and see which ones are okay and which ones definitely need changing. I believe that one definitely needed changing, but I'll soon find out. I don't want to use the new tubes in here if the others are perfectly fine, because I know the tubes that I ordered are new old stock and I don't want to waste them. But I also don't want this radio to be stumbling along with an old tube if I've got a new one sitting over there. I'm actually going to do this first. I've actually desoldered the wire from the 250 volt tap, and I've connected it to the 230, 240 volt tap. And I'm going to switch it on, see what voltages I get. Because the main concern is actually the heater voltages, I am going to monitor those when I switch this on. I'm actually dropping the variac a little bit just in case. Okay, it's at 200 volts or so. Let it come up. I'm going to put it up to 220. I don't want that to go over 8 volts, so let me carry on. 225. Right, we're at 230. That's safe enough. And the dim bulb is bypassed. That really didn't do that much to it, so it won't harm it. It's at 230. If I go up a bit more, I should get it close to where I want that, the limit where that would be, but it won't get there on my supply. Let me try the B plus on here. 95, that's fine. I was worried that this would be too high, but I'm happy with that. So I'm glad I made that change. Okay, block your ears. This is what I've done. Let me put the volume down. I'm feeding a 1 megahertz signal into the actual antenna end of this as if it was a radio station. I've dropped the amplitude as much as I can to get this thing to play the tone through without distortion. And what I'm measuring here is the AC voltage of the actual tone, of the 1 kilohertz tone at the speaker. Now the one thing I can do is I can turn the speaker into a dummy load, which takes away the noise, but still leaves us with the tone. And I'm putting the volume up to max. And now what I'm going to do is I'm going to start changing these tubes, switching it off, swap the tubes and switch it on again, see if it makes any difference. I want to get the same sort of signal amplitude. This is probably the easiest way for me to test that, and that's going to be sufficient for me. So let me do that and I'll tell you what the result was. I've swapped out that first tube, the 1T4. Now that one may require retuning for me to get the full amplitude, because it is in that front end tune circuit and the actual tube might make a difference. Let's have a look at the voltage. Yeah, we had 262. See that? On dummy load we had 262. Let me see if I can... No. That one is definitely weak. I'll put the new one back. Unfortunately, that one is not good. Let me try the other 1T4 on there. No, this one's even worse. The 1T4s are definitely kaput for that position. Doesn't mean they might not work on the middle position at tube 3. Remember, that guy's also a 1T4, but they certainly don't work at the front end. So I'm going to put the new one back. And with the new one back, we're back to 260 something millivolts, 263, exactly where we were. I won't even put the speaker on because that'll blow our ears out. As I said, that 1T4 or those two 1T4s may still work fine here, because the front end one is doing an RF amplification. This one I believe is just an IF amplifier, so it might actually work well here, and I'm going to try them anyway before I throw them out. But actually, let me do that since I've got them out here. Let me see what happens. Remember, that's what we're getting with that set of tubes at the moment. In other words, with all new tubes. And away we go. No. Definitely not getting there. Those 1T4s are dead or very, very weak. Okay, so my 1T4s, I'm glad I ordered two of them. Both of them are needed on these in these positions. Put the old one back and put those away for good. Actually, watch this. I tried the second one on here and it's not as bad as the first one. So that first one is very, very weak and this one is just weak. This could probably stay here, but I'm not going to leave it there. But it's not as bad. So I'm going to make a note that the first 1T4 is kaput and that this one could be used in a pinch if I can't find a replacement immediately. Okay, glad I tried that second one. Just replace the 1S5. I think I know what to expect here. Do I? Well, that's a bit of a surprise. It's weak, but it's not dead. I wasn't expecting that. I thought it was completely dead because when I tried to use this just at the audio section, it wasn't doing absolutely anything. I think maybe the diode is fine and the amplification section, the triode, I think there's a triode in there. I think that might be gone. Now I've tried the output tube and that one is definitely weak. Look at this. No, that output tube is gone as well. Switched it off. I'm going to put that power tube back. And it looks like I've got a whole set of very weak tubes, which means it's a good thing I ordered a full set. Just made a note on the tube that it is weak so that if I need it in a pinch, if I need it desperately to test something, I know that it works, but it can't be relied on to give me its full attention. So all the tubes are back. I'm happy with the result. Actually, I would have preferred some of the tubes to be good, but never mind. The full complement of new tubes, European equivalents, are here. I've got the B plus down to 90 and a bit, 94, which is perfectly fine for a 90 volt set. The heater supply is not quite at the 1.4 times 6 level, but it's a bit higher than it was. So the heaters are nice and comfortable. They're not working at full limit. They're very comfortable. They probably will last a long time. And I've got this radio working, and I'm so happy with that you won't believe. I've still got a problem with one side of the switch that I need to see what I'm going to do about. I don't think there's a chance of me getting a replacement one in time. These two wafers on the side work perfectly fine. On the reverse side, they don't. So I might have to split that up, and make this single function switch. I'll think about it. So there we go. I'm so satisfied, so pleased that I've got my first battery powered or possibly battery powered tube radio working. It's a portable tube radio, and I'd never worked with these tubes, so these things were a little bit fragile for me. But at least I've got the mystery of the dead reception solved for now. I'm going to work on the case, try and get the case sorted out. I'll see what I have to do about that switch, and also work on some alignment, and I'll show you that in the next and hopefully final video. So I hope you've enjoyed that, and if you have, click like, share, subscribe and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links in the description below. Thanks for watching. Bye for now and stay safe.